Welcome everyone to another CTC software webinar. My name is Sean Zerbis. I am the Technical Evangelist and Director of BIM Development at CTC, and I am joined today by our main presenter, Stephen Bunker, who is going to be talking us through the massively important features of the Electrical Productivity Pack. I'm going to get out of the way and just let Stephen take over and begin talking about all of the content that we have developed in the EPP. Stephen.
All right, well, thank you everyone for coming tonight or today. My name is Stephen. I am one of the electrical developers on the MEP Productivity Pack for CTC. And that's what we're gonna be talking about today. So I have one slide for you and then we're gonna jump into Revit. So the whole thing is not gonna be a slideshow. For those of you who are completely unfamiliar with this, or maybe have just are just finding this on YouTube, I want to answer the question, what is the MEPPP? It stands for the MEP Productivity Pack. It is a content library for MEP design in Revit. It includes, it includes a starter project, a sample project, it has Revit families, and it has several other supporting files like a user manual and some Dynamo scripts for your use. And we're going to be going over all of those today so you can really see what's in there, at least from the electrical side. The purpose of the MEPPP is twofold. It is, for one, a get started now package for MEP firms that are completely new to Revit. It has everything you need to get started from nothing, even if you have never touched Revit, you've been in AutoCAD for your entire firm's life. This has everything that you need. The developers of this pack, including myself, are actual engineers. We use the product for our own production work in our firms, and so the developers know what they're talking about and know what they're doing in creating design workflows. But the second purpose of the pack is to provide advanced content for users. Even to firms that have established Revit standards for MEP design, or maybe have been using Revit for a while, not only are the developers of the pack design engineers, they're also experts in the use of Revit for MEP design. The Productivity Pack contains unique features that just can't be found anywhere else. We have put in thousands of hours into work in developing this content so that you do not have to do that, pay for that labor yourself. And we're going to be showing you some of those advanced features today. The purpose of this webinar is to overview the electrical content specifically. You can purchase the Productivity Pack as a whole with both mechanical, plumbing, and electrical all in a pack, or you can purchase just the mechanical portion of the content or just the electrical portion. When we are referring to just the electrical portion of the pack, we often call it the Electrical Productivity Pack, or the EPP. So I'm probably going to frequently refer to the EPP in this presentation, and that's what I'm referring to, just the electrical portion of the pack. I want to give you information in order to help you determine whether the EPP would be beneficial to your engineering firm. I'm going to try to briefly look at all the subdisciplines, power, lighting, fire alarm systems, and I'm going to cover what the pack does and what is in the pack. For the sake of time, I'm not going to cover, this isn't a tutorial. I'm not going to show you how to do anything or how anything is done. I want to try to give you enough information for your decision making. I'm going to first look at the pack as a whole, and then I want to look at some specific family content and features and some specific workflows, and then we're going to take a look at the sample project so we can see the content in action. I'm going to go fairly quickly, but it will be available on YouTube if you want to pause and look at things more closely. But I just want to cover as much content as I can in the hour that we have. If you want more information than we have time to cover today, please know that we have a pack available for download for free that includes our 350-page user manual. The manual provides all the detail you need to use the product and has links to tutorial videos on how the product works and explains how to use the product, the content. You can also contact your reseller to schedule a demonstration for your firm that's personalized for you, where you might have some more time to answer some more, ask some more specific questions. And then also I want to answer your questions. Please ask questions about the content as you have them. And I'm going to try to pause periodically to see if there are any, and Sean has permission to interrupt me if something pops up that's relevant. So now I'm going to close out the PowerPoint and go to Revit. So I'm going to be working in the sample project. The sample project is one of the files that's available for download if you purchase the pack. This is a full building that is a completed engineering design modeled in Revit in order to show off how the content works. We have done taken measures in order to show different workflows. So there's a lot in here, way more than is needed for this size building. We've just put stuff in here so you can see how it works. I want to look at the overall project by stepping through the project browser, just sort of use this as a roadmap. I meant to start here so I could show you what this does. I'm going to just expand our views. You can see that our views are organized into top level classifications or types. I'll expand them so you can see. So you see that we have mechanical and plumbing and fire protection and things all in here visible. The content is designed for mechanical and electrical to work within the same model. If you do not buy the mechanical, or if mechanical is working in a separate model just because that's the way you like to work, most of the stuff will still work. And there's still ways of doing everything. It's just some of the collaboration workflows will not be quite as seamless. So for example, when mechanical places an air handler, like this rooftop unit that's here on the roof, if we're working in the same model, we on the electrical side circuit that piece of equipment directly. We don't have to have an equipment connection family or anything. We just circuit it, and then we coordinate with mechanical the power requirements for it. Well, you can't circuit through a link. So if you are using if mechanical is in another model and you're linking it in, there's still an equipment connection family that still works with the mechanical equipment schedule. It just isn't quite as seamless. You have to duplicate some information. So if we go up through our views, our top level classifications is just our first sort of level of organization. Our 3D selection box is just where the automatically generated 3D views go. Revit's analysis capabilities, I'm going to filter this back to electrical. So even if you're working in the same model as electrical, we have some browser filters set up where now this hides most of the mechanical stuff, so you don't have to fumble through all of their stuff while you're working on your things. Revit's analysis capabilities aren't that robust for electrical, but we do have some lighting analysis here that you can take a look at. The construction documents is where we keep our views that are intended to be placed on sheets. If we expand, say, power, we see that we have 10 floor plans already set up, and each floor plan is actually also divided out into a north, south, east, and west. This is all set up so that you don't have to. But if you're working with a smaller building, which most people probably are, you also do not have to go through the tedious task of deleting all of this stuff. In the content that's provided is a Dynamo script that you run, and you just step through a series of questions saying what floors you need, whether you need the north, south, east, and west dependent views, and even whether you need certain subdisciplines. And the Dynamo script will strip out everything that you don't need. So if this were a real project and I've only got 2 levels here, I would only see level 2. And this building isn't big enough to be split up across multiple sheets, so I wouldn't have the dependent views. They would all be gone. So it's not a tedious task to set up a new project. Coordination, project setup, working views, that's pretty much what it sounds like. We've tried to make projects set up as seamless as possible, quick as possible, so that you can get up and running with your new stuff, and that's all described in the user manual. Test elements is a view that only exists in the sample project, or a classification that only exists in the sample project. We strip it out of the starter project. And to be clear, the starter project is like a template file for you guys to start your own projects. So when you start up a new project, you won't start with a sample, you'll start with the starter, which has all the sample material stripped out of it. Let's take a look at, say, electrical equipment test elements. The test elements reviews where we have all of our family content placed. So every type of every family is placed for viewing. We on the developer side use this for testing. So if we need to edit a family, we get a new family, we'll lay it out here so that we test it, make sure it works right. But we leave it in here for you guys because it's also great to just view all the content, to see what's in here, to play with it without risk of messing up a project. So we have all of these here, and every single one of these, every single family that's in the product is laid out here so that you can explore. We're going to come back to test elements to actually look at specific family content in a minute. If we keep going down through here, legends, we're not using legends for electrical. I'm sure you know that Revit's legends leave much to be desired in the way of functionality. We do, of course, have symbol legends. So if we open up our title sheet, say, if it'll open. So this is our symbol legend. We have one set up. I'm sure you'll want to edit this to match exactly the way your firm wants to show it, but here's a starting place for your use. And the way we've got this set up is pretty nifty to make it easy to use, to make sure that the symbols on the legend actually match what's on the drawing. It's not just lines and text. So if we go back here, panel schedules. Now, in the starter project, you're of course not going to have any panels schedules because you're not going to have any panels. It's an empty project. All of these panels are part of the starter, and you can imagine for a building this size, well, it's really just a two-story building that we're dealing with. You don't need this many panels to do that design. We've got all these in here in order to demonstrate how they work. And so I would like to take a look at some panel schedules real quick. And to do that, I'm going to open up a couple of sheets. We've got the 800 series sheets has our schedules. So the first thing I want you to see, if we go up here to manage templates, our branch panel here, we have only one panel schedule template. In the past, we've had, I'm sure you've seen, several here, MLO, MCB, different numbers of breakers, feed through lugs or not. We've been able to consolidate all of that into a single schedule that works for everything. This works no matter what kind of panel you have, this will work for it. So this is an example. This is the panel schedule that we have. It has all this information. We're hopefully going to have time to talk about this panel ID in a minute. We have bus rating, we have neutral, we have feed through lugs, all this information. So main types, this can be MCB or MLO. These things are actual numbers. So if you're used to some of Revit's default content, some of the amperages or SCCR is text and not actual numbers. These are actual data format. I think I mentioned feed through lugs. Let me find one that's got. Yeah, so this is a panel that has feed through lugs, and whenever a panel is said to have feed through lugs, and this is using Revit's actual built-in feed through lug feature that's new in Revit 2020, this message comes up that just makes clear that there's some loads coming from feed through lugs in these totals, and it's not just a sum of the branch circuits. So that just makes it clear for everyone. I think Revit has a panel by default that sums up feed through lug totals separately from this, and if you want that, you can add it, but I don't know that's all that necessary for most people, so we've just got it included here. And then, yeah, so switchboards. We have 3 different ways of showing switchboards, depending on the needs of your project or your personal preferences. One, I'm sure you know, the electrical designers out there will know that horizontal buses and switchboards can have a different amp rating than vertical buses and switchboards. So for example, this switchboard, I have a 4,000 amp horizontal bus rating, but only 3,000 amp vertical. And if you're in the nitty-gritty of design and not just leaving it to the equipment manufacturer, you might need to justify load on those vertical sections and separately, individually. And so what we've got here is this is a main section in section 1 and section 2 of a switchboard or switchgear or MCC. You can use this for anything you need. And we're not duplicating information. We don't have all the header information on the sections. It's just flowed. And then over here, we have the sum total current demand on the overall switchboard. If you don't need that much detail, but you still want to circuit the sections separately, here's another one where we have a header and we have the 2 sections and we have a footer for the entire switchboard, and you can circuit the 2 sections separately, but there's not a load summary for each section. Or if you're even simpler than that in what you're doing and you just need a single schedule, this is basically like a panel board schedule for a switchboard, except it's a single row or a single column instead of 2 columns. So 3 different ways of doing it depending on your needs and your preferences, and we hope that that will be flexible for pretty much everyone's needs. So that's all I have for panel schedules. Let's just quickly go through here. We don't have any reports for electrical. The mechanical uses that for energy analysis and some things. All of our sheets are already set up, so you don't have to create them. The dynamo routine, we've got dozens here because we've got such a big, we've got 10 floors, right? The dynamo routine will strip out what you don't need automatically. So you don't have to go through and delete all of these if you don't need them. Families, we'll talk about families. Next, we do have a couple of groups set up for electrical that you can read about in the user manual. And then of course our links. So we have link placeholders in here. So you can reload from, when you get a new model in your starter project, you can reload from. And this allows us to save all of our view settings and view templates for links so that we don't have to mess with view templates every single time we get a new model. So that's all I have for the overview. I'm going to go into specific content and workflows next. And to do that, I'm going to go to test elements. Are there any questions so far about what I've covered while I make my way back up to test elements?
There are no questions currently in the queue for you, Stephen.
All right, let me close all. Okay. So now we're here in test elements, and I want to start with panels. Excuse me. So I'm not going to cover every feature for every family that we have, but all of our families are built out with a similar thought process behind them in making them simple and foolproof, easy to manage, easy to use. And so even though I won't be able to cover everything, all of the electrical families have the same flavor, so to speak. I'm having to change my design option to test elements. Give me 1 second. While
quick question I want to throw out there that was just thrown into the question window. Why do you have 1 column and 2 column? That's the specific question.
What do you mean 1 column and 2 column? Is that for the am I done? Is that for this, like 1 column, 2 column? Yeah, I was going to cover it later, but I could just show you real quick. We've consolidated our panel boards. These are all the panel board families in the project. Excuse me. My kids gave me a cold, so I'm trying to talk through that.
And yes, that is what the question was referring to, are the panel boards with the names 1 column versus 2 column. So
yep. I'm going to come to that. It'd be easier to show you what we've done here, and then I think that the question will answer itself. So if not, then you can clarify. So the first thing I want you to see, I'll skip ahead to this part that would answer that question, is that all of these panels here, even though they all look different, they're the same panel. They're the same family. In versions past, we've had literally dozens of panel board families that were all the minutia for the differences in panels were different families. It was just difficult to manage. Revit doesn't like it when you change families for something that's circuited and sometimes breaks the circuiting. So we've combined all of that functionality into a single family. So here we have a flush mount load center. Here's a surface mount distribution type, square to eye line type panel. You can even do semi-recessed surface mount panel boards. Here's a multi-section panel board. Normally this is a 2-section, but I was playing with it a few minutes ago. You see I've got 5 sections there in a single instance of a single family. And I can change, there's really no limit to how many you can do. You can change that back to whatever, and you can also change the spacing in between. So here we have multi-section families. So we put all of these into the same family so it's easier to manage, and it causes less problems when you need to change. It's easier to change types in Revit than it is to change families, because changing families can sometimes break circuits. The only thing that you can't do this way is whether it is a single column panel, a 2-column circuits across panel, a 2-column circuits down, or a switchboard type schedule. The only thing that this controls is what type of schedule, what type of panel schedule template are you allowed to use with the panel. That can't be controlled within the project environment. You have to create separate families for that. And so that's why we have 4 different ones that are labeled differently. Because all 4 of these families are exactly the same, except they use different panel board schedule templates based on your particular needs. Most of us in North America probably aren't going to use 2-column down, but 1-column panel boards do exist, and you might want to use a switchboard schedule for a distribution type panel. If that's the case, you need to use the appropriate family. Otherwise, this family can do it all, and it can do even more than I've showed you. The next thing, notice that I was able to pull this away from the wall, but this here I can't pull away from the wall. So this family is hosted to the wall, and you can see here it's hosted to the wall. This family is not. It is hosted to the level. So we now support unhosted content. All of our electrical content can now be placed either hosted or unhosted. And the coolest thing about this is that if I select both of these, it's the same family and the same type. It's not even a different type. So you don't have to manage if you've got some projects where you're saying working with a CAD background, so you don't have walls to host them to, and some projects where you're working with an architect in Revit, and you can host. You don't have to maintain 2 separate sets of libraries for hosted and unhosted content. We've been able to build it all into a single family and a single type. And the way we were able to do that, and then how you use it, is in the user manual. So all of the electrical content can be placed hosted or unhosted: receptacles, lights, panels, equipment, everything, except for things that doesn't make sense for it to be vertical hosted, like switchboards. Switchboards are always on the floor, so they're never going to be hosted to a wall. So that would be the exception. Let's take a look at this panel board. You see we have clearance. This clearance depth, in fact, I'm going to go to a 480 volt panel, like, yeah, here's a 480 volt panel that's recessed. This clearance depth is calculated automatically according to the NEC based on the voltage to ground of the panel per NEC 11026. You can override it manually. So this right now is 48 inches. If I just want it to be, I don't know, 1 foot, I can make it. So you are always in control. You can move the panel to the side with this grip. And no matter how far you move this grip, it will never leave the face of the panel, which is a new feature this year. You can change the condition. By default, the condition, and these are the conditions in NEC 110, they're set to 3. But if I want to change this to 2, it should move to 42 inches. If I change it to 1, that should move to 36 inches, again, per the NEC. If you have large equipment and you don't have unobstructed egress, then you need double clearance. Rather than calculating that in your head, you can just click a checkbox and it will double the clearance. The height is 6'6" by default, and the width is 30 inches by default, but the clearance will never be smaller than the family. So if the family is taller than 6'6", the clearance will be to the top of the equipment. Same thing for the width. Let's go here. Let's go to this view. We have dedicated space, and our dedicated space can be adjusted via a grip, which is also a new feature this year. And not only can it be adjusted via a grip, let's say this is the structure, the structure above. And let's say all these panels are in an electrical room. You don't even have to use the group. You can align. I can check multiple. That's what I want to align to. And I can just align every single one of these to the structure super quick. So that's a huge improvement over what we've had in the past. Let's take a look at one of these in 3D. If you're in Canada, I don't know if any of you out in the audience are in Canada, but this will be on YouTube. We have built-in support for Canadian electrical code now. And the way that this is done in Canada, you don't have the same type of working clearance that the NEC has, nor do you have dedicated space. And so we have built in where you just check that you're the Canadian electrical code, and it will change to comply with the Canadian electrical code. So it's just on the face of the panel, and this distance here is 1 meter. So you do not have to do this per family. We have a project-wide setting where you can change the entire project to Canadian electrical code. So don't worry, it's not a tedious thing that you have to do to all the families individually. Let's just step through here. Transformers, we've got busway. Hopefully we'll get to the project, the sample project where I can show you busway. We have busway modeled, and we do support busway now with elbows and bus plugs, both for the distribution type busway that you would see in manufacturing facilities with the horizontal runs, and the large 3,000 amp busways that you run up through high rise. We can do both of those now. Switchboards, clearance, ATSs, underground stuff, utility stuff. So all this is here. Electrical fixtures. Ceiling mount, we've got disconnects, we've got receptacles. Again, all of these can be hosted or unhosted. Floor, ceiling, switches, cord reels. So this is cool. This is a generic electrical fixture. So you notice all of these here are the same family. If you need different symbols, that's basically something in a shape, whether that shape's a square or a diamond or a circle, then that's all the same family, because that's just all be controlled via geometry. And instead of having dozens of families that you have to manage and work with, and if you find something you need to edit one in some way, you got to edit 24 of them. This is all a single family, and these graphic options are controlled just via some checkboxes in the type. So here I've got one set here for demonstration where I can go and type. I could just change some of the checkboxes, and I have a different symbol. With a foot or not, with it can do pretty much anything you need. So we hope we were excited we were to get that to work, and we hope that it'll make things easier for everyone. If you need a one-off symbol, right? I don't know, you've got some weird device that you've got to put for something and you need a one-off, you could just make a symbol and put it in your symbol legend, and there you've got it. So you don't have to make an entirely new family. You can just make a new type. This is plug mold. This plug mold calculates according to the NEC. So the NEC it's 180 VA for 5 feet, or 180 VA per 4 feet, depending on how dense the devices are. And this calculates. So see, this is 5 feet and 360 VA, but if I shrink this down with my handy little grip, now that calculates to 180 VA. And I can have there is an option in here to have a current limiter as well. So if you are putting like a 2 amp current limiter on it, then it will calculate per the current limiter, which is allowed by the NEC. So that is a new feature this year. Fire alarm devices, again, we had dozens of fire alarm devices, and we've consolidated those all. These are all the same family, even though they all look different. All these are the same family. Actually, that one right there is different. All these are the same family. Our symbols now conform to NFPA 170. Previously, they didn't, but if you liked our old symbols, you can still configure these families to work with the old EPP symbols. The way that this visibility graphic, that the graphics symbols are controlled is basically the same way as the generic device I just showed you. So it's just a lot fewer families. The families are more complicated, but it's fewer and they're not hard to use. They're complicated to make, but they're not complicated to use. We have coverage hatches for fire alarms. So this is a 15 candela, which I think is 15 by 15 feet. That's in type properties. The default for all of these is set per NFPA 72, but you can edit them if you need to do something else. So you can turn that on and off in order to see the coverages. Same thing for, say, the ceiling, except the ceiling, you can tell it 10 feet, 20 feet, or 30 feet per NFPA 72 because the family doesn't have a way of knowing how high it is in the room. The detectors, same thing. These are all the same family that are have different graphic options. And again, they are now NFPA 170 compliant. This is a generic device, works just exactly the same. This generic device, we have one in every family category, both a ceiling floor version and a wall version, and they all are exactly the same family. And then some panels. Lighting and data devices, similar stuff. Lighting fixtures, we need to go to a ceiling plan to see lighting fixtures well. So there's a ton of stuff in lighting. We actually have a really good video out on YouTube that overviews the lighting. So I don't want to spend a lot of time on that. I'd rather cover some new stuff. The lighting was new last year. So if you bought the pack last year, this was all new there, but it's all similar stuff. Like I said, it's all similar flavors. And then security and nurse call devices. So again, similar flavor of type of stuff.
Stephen, there was a couple of questions that came in that relate directly to what you're talking about right now, and I think this is a good chance to kind of throw that out there. Across the electrical, fire alarm, lighting, security, nurse call, all of that, those are all using that generic symbol methodology, correct?
Where appropriate, yeah.
Where appropriate, right,
yeah,
right.
Where appropriate. Mm-hmm.
And additionally, every one of them per their category, again, where appropriate, they are using the proper electrical connector in that category, right?
Yes, they are.
They are actually a three-dimensional quote-unquote family that is using the symbolic representation that also has the power connector and some graphics to go along with it.
So all of the quote generic devices, basically, if you look at it in 3D, is a junction box. And it can be surface mounted. So here, I'll make this surface mounted. Right, it could be surface mounted or recessed. And this is a square box, but if it were a rectangle box, you could also turn it horizontal. And it's just a blank faceplate because it's just something. I mean, there's tons of devices. It's just something in an electrical box. And a lot of times the electrician just installs the box and then some low voltage contractor comes in later and pulls the cable and puts the faceplate on. So the only thing that really matters for us is what does it look like on plan? And so all of these options, you can control the size and shape of the box and whether it's horizontal, vertical, or surface or recessed for the actual 3D model, but all the options is the symbol. So like I said, all these symbols are the same, even though they look different.
And one follow-up question that commonly comes in around this also is, and of course, all of these items can be tagged using traditional Revit tagging methodology.
Yes, certainly. Yep.
One very specific question related to tagging, Stephen, that I want to just kind of follow up with, as you were showing data devices, there was a question about, can you tag the IP address? And I don't recall if that was something that we added, if it existed or not in our content.
We don't have anything specific for that, but we do have labels, and you can circuit it to a panel. I'll be honest, I don't know much about low voltage design myself, but you can put anything that you want and you can tag it. So I'm going to say yes, but you may need to make a project parameter and assign it to your data device category in order for it to work.
Or use one of the parameters that already exists that isn't explicitly called out as IP address, but you can still leverage that to indicate some data connectivity.
Exactly. So, you know, we have like this, for example, if you go in here, there are labels already here, like identity mark, that may be suitable depending on what you're doing. So again, it just depends on what you're doing. But worst case scenario, you just go create a project parameter and assign it to data. And you can do it pretty easily in Revit.
All right, that's it for now. We'll continue on.
And yeah, if you did that, you'd probably want to create like an IP address schedule so you can manage them all in one place. So now I would like to, let's see, where is it? I think, am I in a ceiling? I am in a ceiling plan. That's why I'm not seeing what I'm expected to see. Okay, so this is probably the coolest feature that we've developed this year. And I have some windows that I pull off over the sides so we wouldn't have to wait on them to open. This is an equipment connection family. If you're working with mechanical in a linked model, this is the type of family that you would place in order to represent and circuit mechanical equipment. This family actually has all of the same symbol options as the generic devices. In addition, it has this motor symbol, and you can actually also just do, there's a bus symbol, there you go, a bus symbol, or you just do a dot symbol if you just need a placeholder, and you just place a dot. But we are now doing a ton of electrical calculations in this, and not only in this, but in all of the mechanical equipment family. So it's in this family, and this is what I'm going to use for demo, but these calculations are in all mechanical equipment family, and I'm going to show you what they are. So this equipment connection schedule up at the top is the sheet schedule. This is what's actually placed on the sheet. And this one down here at the bottom is our working schedule. So you see the working schedule has a lot more information. The equipment connection schedule is placed on the sheet, just has the information that we want to show on the sheet. And this particular item that I have placed here is this one that is identified as underscore demo. So some filtering, sorting, family type. So we go through here. I'm going to skip over some of this. This all is interesting features, but it's not really what I want to talk about. Here's what I want to talk about. So this demo, where am I at? Here it is. It's this row, second. This is a 40 volt 3-phase family. Has 3 poles, which is calculated automatically. Let's say that this is a motor. Okay. First of all my stuff's zeroed out. 0 horsepower, 0 FLA, 0 power. If I come over here to my, might be better to look up here. Conductors and conduit and everything, it's all blank because we don't have anything in there. I just placed this family. But now let's say that this is a, I don't know, a 30 horsepower 40 volt motor. So I'm going to come over here. I'm just going to type in 30. And I have my sheet, my cheat sheet from the NEC, and I'm looking here to confirm that a 30 horsepower motor at 40 volts is 40 amps. Okay. Well, I didn't need to look at because it calculated it for me according to the National Electrical Code. It calculated motor FLA. It calculated apparent power. Let's go up here. It calculated apparent power, FLA, MCA, overcurrent protection. It calculated number of runs, the number of phase conductors, the size of the phase conductor. Copper is a selection, so we selected copper. The size of the neutral, the size of the ground, the size of the conduit. It calculated all of that for me. And it does that according to the National Electrical Code or the Canadian Electrical Code, as we'll see in just a second. It takes this, we have all of the code tables built into the family in lookup tables. And we also have options set that can be set project-wide, not per family. You can do it per family, but you can do it project-wide where, for example, for overcurrent protection, it's Article 230 the table 230 dot whatever it is, where it says the multipliers for your different types of overcurrent protection, they're built in here. Okay, this is set per the NEC or the CEC, but you can change it. So like you can do an inverse time at 2.5, but that's big. A lot of engineers might say, I don't know, 1.75 is my standard. So you can actually change this project wide. And then for each one of these, you can select all of your calculation options, whether it is copper, so you can do this in the schedule or in the family, whether it is a copper or aluminum conductor, whether it needs a neutral, whether it needs a ground, maybe it doesn't need a separate ground because you're relying on the metallic conduit, the type of overcurrent protection. So if it's an instantaneous trip or inverse time motor type connection, all of these options are here for both the National Electrical Code and the US National Electrical Code and the Canadian Electrical Code. And it tells you, if you select it, it's not in the schedule, but it's down here. It tells you where the data is coming from. So if you've got a single phase motor, it's going to use a different NEC table than a 3-phase motor because it's a different table in the code. So this tells you where it's coming from. And if I change this to Canada, which again, this can be done project-wide, I'm just doing it per family here. And I leave this selected. Now this changes to the Canadian Electrical Code tables, okay? So this will calculate a ton of stuff for you, and it's really intended to get you a good starting place, especially early in design. Of course, it still needs engineer review, and of course, you can't overwrite every single thing. So let's change this back to, oh, and to be clear, it does linear interpolation as well. So let's see, the NEC code skips from 30 to 40 horsepower. So if I type in 32, that is going to interpolate, do a linear interpolation between the values in the table. If you're not using, if this isn't a motor, you can just input apparent power. Say this is, I don't know, let's say it's 30 kVA. And now it'll calculate the rest of the values for you. So whatever data you enter, it will calculate the rest. Now it will let you put in garbage. It will let you override because we're not preventing you from overriding and making engineering decisions. So let's say make this a power factor of 1, then my real power is 30 kilowatts. Well, let's say I want to override that and say that's 50 kilowatts. Well, 50 kilowatts. Well, it's garbage that 30 kVA at power factor of 1 is equal to 50 kilowatts. But the control is ultimately in your hands. You can override every single value. You're not just relying on this. So we are really happy about it and are glad that we were able to get it work. And we hope that it shaves some time off of your design where you could just hopefully check it and find that it's right. And but you have the ability to override if necessary. Some things it can't do, it doesn't do what is it, voltage drop. It doesn't do correction factors like for more than 3 current carried conductors or for different ambient temperatures. It does do jam ratio. So if it calculates jam ratio, and if it finds that the jam ratio is in the problematic range, it automatically increases the conduit up 1 size. And it reports the final jam ratio to you too, over here. It shows, so in our schedule here, we have panel and circuit. And then our disconnecting control, these are just text entry. So that you can just enter in what you need for this particular thing. If you don't need all these columns, you can just hide the columns. Like for my own stuff, I usually don't schedule the starter and control separately in the schedule. I just have a disconnect, so I would just hide these columns. I don't need them. But it's here if you need them and want them. So these calculations are built into every powered mechanical equipment family. It is built into this family, which is mechanical equipment. It's also built into the a direct power connection electrical fixture family. So, and the way that it's done, how it's used, and also the engineering sort of methodology behind it is in the user manual for engineering review. if you want to look at it to make sure that you like how it's being done. So that's honestly, I think the coolest new feature that we've got, and was excited to show you. But that's all I have for the specific workflow. The next thing that I wanted to do was to look around the sample project, explore, unless anyone has any questions right now.
There was a couple of questions that related to a previous segment when you were talking about the power panel.
Okay.
The question related to double tubs. When working with the double tub and have one panel 1 to 42 and perhaps the other 43 to 84, is that functioning as one might expect?
It can function however you want it to function. So people have different ways of doing things, okay? And we have it set up so that you can do it the way that you want. So if we go back down here to the sheet, here we go. So like for me, my design, when I have a multi-section panel board, whether it's 2 or 3 sections, I do not usually show separate. In fact, that was one thing I was going to show you in the sample project. So let's just go to the sample project and I'll show you exactly where we have this, where we're doing this. Here is a multi-section panel board, and then here also is a multi-section panel board that even turns a quarter, okay? This here is the built-in Revit method of doing multi-section panel boards with feed-through lugs, where this is the main. It is a feed-through lug. It's circuited to the switchboard, or actually it's circuited to the transformer. This is section 2, and it is circuited via feed-through lugs to section 1, and it's continue numbering. And this is section 3, circuited to section 2 via feed-through lugs in Revit. And that panel schedule for that is laid out on the sheet. I think here. Panel board EL1, 1 through 42, 43 through 84, and 85 through 126, okay? So this is sort of Revit's way of doing it, okay? But, I mean, personally, this is a lot of work, modeling. I don't ever do it this way. I do it like this, where if I've got a 2-section panel, or this is actually a 4-section panel with 168 circuits across all 4 sections, I just put it in a single schedule because it's all at least to my mind, engineering mind, it's all the same. It's all the same load on the total sum of the panel. They're all rated the same. So I just do a single section. So you can do whichever way you want. This is the way that you would do if you're using this multi-section panel board here. If we go back to our power plan. So this is a multi-section panel board, and down here on my max number of 1-pole breakers, I have this set at 168. And this is what's scheduling. So you can do it either way that you want. Both ways will work. This way is easier in my preference, but the other way, if you want the separate schedules for the panels, you can do it that way too.
You got a thumbs up and a cool from the listening audience on that one.
Great, I'm happy, thank you. This is an example. I just did this so I could show you how you can turn corners using this method. Of course, if you're turning corners with this, you just place each individual section on the new corner. But this here, I want to turn a corner. So what I've done here, there are so-called, I usually call them dummy panels, but no power. This has no power connector. It is geometry only, and it's there just as a placeholder if you need a placeholder for something, but it doesn't need to be circuited. So here I have this where I'm turning a corner, but all of my circuiting is actually happening here, okay? This is one where this panel and this panel is circuited to the transformer. Well, you can't circuit, or you can't do a load summary on a transformer in Revit. If I click this, there's no option up here to have a load summary or like a panel schedule. But sometimes that could be necessary if you want to make sure that you are not overloading your transformer. Sure, you can see the connected load on the transformer here, but that isn't going to tell you demand load. And so there's a workflow built in here where, and you can just see how this is done, and it's also described in the user manual, where here I have a load summary for the transformer that shows the 2 panels and what's on it and the total demand load that is on the transformer, not just connected current. These are the 3 switchboards. So these, I've got 3 switchboards here, and there's 3 because I'm showing you the 3 different methods of scheduling the switchboards. Here, I'm also showing you that we can have rear clearance. So this is a switchboard that has both front and rear clearance, probably most likely switch gear, but you can have front and rear clearance. Here is our busway. So I'll just show you, let's do a 3D of the busway. So this is a busway. I'm gonna make a 3D section of this. Let's cut out the ceiling. Yeah, expand this down. I've got several different busways modeled here for you guys to see. Here's one that is, for example, connected directly to a switchboard via a flange. And then, of course, a building this size you would never do busways, just demonstration. The busway has clearance built in, so it's a little hard to see in this view, but there is clearance built into the busway, so, and that's adjustable. The busway, we have multiple manufacturers set up, so you're not having to enter the dimensions directly. We hope to add more manufacturers in the future, but right now we have lookup tables with the manufacturer's dimensions for various types of busways. That is helpful. Here we go through a wall, we turn the elbow. This elbow, the length of the 2 legs of the elbow is adjustable via a grip. So same thing here. All of these things are done by grips. So see, I can expand that grip out. Okay, and then the elbows also, you can change the grip. So if you need to have an elbow right next to a wall, you can't connect the busway in a wall. You have to order an elbow that has 1 leg longer that'll go through the wall. And so you can do that here. And then this turns the corner, and this goes up to, there's another elbow, a flatwise elbow instead of an edgewise elbow, or whichever way they call it. Forget. And then this goes up to 2nd level, and there's a bus plug connected to the busway. And then these panels are circuited to the bus plug. If we come look over here, here's another, and we cut out that wall. Cut out this wall. Here's another one, but this is a tap box. So if you were taking your conduit underground from the switchboard and coming up into the tap box, there's your tap box, and then your busway's on the tap box, and then your bus plug is on the busway there. And there's more features about busways than that we're running out of time. Let me show you just real quick that the horizontal. So here we have some busways set up that would be like in a manufacturing facility where you've got these horizontal runs, and there is a tap box or a feeder unit. And then we have, like, there's a bus plug on it. So, and you could do, you would never do that. I'm interfering with the duct, but just ignore that. Of course, you would, this is weird, you would never do this, but I've got it modeled here so you can see the kinds of things that we can do. We don't have every fitting possible. We don't have double elbows. We don't have custom angle elbows. We don't have offset elbows, but we do have crosses, and we have crosses and T's and elbows in both orientations that they can be for each of those. And of course, straight sections. The last thing I wanted to show you was circuiting, and I wanted to show you what in the world this little panel ID thing was here. But is there any questions before we get to that?
There was a question that I think it might make sense to answer just before you dig into that next topic. You'd mentioned it a couple of times, and it was asked twice in the questions process about how to change between US NEC and Canadian's CEC standards as a whole. You mentioned that it doesn't have to be one by one. Would you mind showing that process for the team?
Yes, I'm not going to click the button because it takes a while to churn. But if you look at our cover sheet, we didn't talk about the splat, like the starting view here. But here's the starting view. if it opens. I've got too many views open. Sorry, guys. So these are project settings. So I think I mentioned the OCP multipliers. You can view them here. You can change some text size project-wide. Here's the electrical code selection. If you open this, you can just check that box. Just check that box right there, and every single family, electrical family that has Canadian options will be checked. So I'm not going to check it because it takes several minutes for it to churn through and edit all of those. The other thing here is minimum conduit size. I think I told you that we're calculating conduit size automatically, but you can have a minimum. A lot of engineers like 3/4 inch minimum. You can make it 3/4 inch, you can make it 1/2 inch, you can make it 2 inch if you want. Same thing for minimum wire size. The wire size will go from 14 all the way to I think I did it up to 1,000 kc mil, but still a lot of people have 12 as a minimum. So you can set this as a minimum and it'll never do anything smaller than a 12 in automatic calculations. You can override it. So even if the automatic calculation says 12, if you want to override it to a 14 or smaller, you can. But this is for a calculation. So these are all schedules that are here, and then there, of course, you can navigate to them from the project browser. And these are also all the generic devices. You can change the size of their symbols globally. Really, this isn't so much to change the size, but to make sure they're all the same size. We like consistency, so we want them all to be the same size. And so if any of these values are blank, then one of them has been edited on a per type basis. And so you might want to fix that, find it, fix it. Anything else?
Nope, I think you have 3 more minutes to talk about your final topic. I think was circuiting.
Again, we want to match, we want to do whatever anyone wants to do, okay? We want to, as much as reasonable, we want to accommodate your workflow. So if your workflow is using arc wires, you can use arc wires, okay? We've got it here. So all of level 2 is circuited using arc wires. But in Revit, it's actually faster to use tags. And that's what we've done here. This is a circuit for this here, and this is tagged with C33. This C is a code that we have given to the panels, and in order to say which panel this is. And if we go back over here to the schedule, we have a schedule here, and I've placed this schedule on every panel schedule sheet, so it's absolutely clear to the contractor. Panel ID C is actually panel L1A. So you can just tag the circuit and you don't have to worry about arc wires. You don't have to worry about, having weird codes built into your panel name, like I've seen some people do in order to do this. You've got this here. And then this is described. You may want to adapt this for your purposes. If you want to do it slightly different, you can. Of course, you wouldn't need panel ID if you have short panel names to begin with. Like if you're just doing A, B, C, D, you probably don't need it. But we have wiring descriptions, but that's messed up. I need to fix that. But then we also have, where's it at? Oh, I know it's here. I was looking around in front of it. We have a description here of how exactly those IDs work for the contractor. And then also same thing for like lighting device tags, top values, the fixture ID, panel ID, circuit number, and then switch ID. And same thing for our device tags. So panel ID, circuit number, switch ID if you have a switch. We can do power switches and 3-way switches in the project. There's another video about that. Don't have time right now, but Revit can't do 3-way switching, and Revit can't put power electrical fixtures or mechanical equipment on switch systems. We can. So you can go look at how we're doing that. It's really easy to do. So covered a lot. Hopefully you guys got a feel for it. Any last minute questions, Sean?
There are plenty of questions. I will follow up with you about those questions in the future, and we'll follow up with the askers of those questions privately, separately from this, as we are out of time. I want to thank everyone for their time that they've given today. Thank you all who attended. Stephen, thank you for your fantastic presentation. We always look forward to seeing you all in future CTC webinars. We have other MEP Productivity Pack webinars planned. Check our events page on the ctcsoftware.com website to know when they're up and coming. And of course, again, this webinar was recorded and will be post-processed and up on YouTube, should be later today, and you should be notified about that. Any other questions that you do have about this pack that you perhaps didn't get a chance to answer or ask today or didn't get answered, feel free to reach out to us directly. We want to make sure you have all the information. And so feel free to reach out. You've got our contact information again on ctcsoftware.com. That's probably the best way to get a hold of us. So with that, thank you all. Have a fantastic day, and we'll catch you all in the next webinar.